be upon you and hello everyone. This is lecture video for our SMN3043 assignment 1. Before we begin, I humbly represent our group member for the assessment.
Assalamualaikum and good day everyone. Today we will analyze a tennis ball hitting straight upward considering air resistance and gravity. So we will solve 3 parts. So let's begin.
AMIRUL, if a mass of tennis ball is 0.05 kg and initial velocity of 2 meter per second, what is the function of ball velocity in the function of time? Can we use linear differential equation to solve it?
Of course, first we need to identify this situation. All information are given like this. Next, we know that the gravity force F gravity equal to mg, air resistance Fa equal to 0.5 v, where v is a velocity of the ball. And we can define that the net motion of this equation F net equal to mg minus 0.5 v. This net force cause the change the velocity over time. So we apply Newton's second law. F net equal to ma, F net equal to m dv dt. Thus, the equation become m dv dt equal to negative mg minus 0.5 v. And we simplify it and become this equation. And substitute it that with the value we know before. And we get dv dt equal to negative 9.8 minus 10v. Now, to define the function, we use linear differential equation by method of solution. There are 5 steps. First, linear differential equation. Rearrange it until it becomes same with this formula, which is dv dt plus 10v equal to negative 9.8. Let's say this is equation 1. Second, identify pt and find the integrating factor of the vt, and we get the vt equal to exponent 10t. Third, multiply first equation by vt, and we get the second equation. Next, the left hand side of the second equation is a derivative of the vt and y. Let it become the third equation. And lastly, integrate both sides of the third equation, and we get the equation is vt equal to negative 0.98 plus c exponent negative 10t. Now, apply it with initial condition. Substitute 2 into the vt, and we get the value of c equal to 2.98. And the final velocity function is vt equal to negative 0.98 plus 2.98 exponent negative 10t. I will pass it to my friends.
To find the time at which the ball reaches its maximum height, we use the principle that the velocity becomes 0 at this point, noted by vt equal to 0. Using the velocity equation derived in question A, we set velocity to 0. To solve the time, first we have to find exponent negative 10t in the equation. So we got exponent negative 10t approximately equal to 0.3289. Next, by taking natural logarithm, which is negative 10t equal to ln 0.3289, thus the answer show the balls takes approximately 0.111 seconds to reach its maximum height.
I have a question. How do we know that the ball reached its maximum height when the velocity is 0?
Thank you for the question, Dini. This is because at the maximum height, the ball momentarily stops moving upward before starting to fall back down. At this point, the velocity becomes 0 since there is no upward motion anymore.
Question 1c. If the tennis ball is hit from an initial height of 1 meter, how high will it reach? Well, if the ball is hit from the height of 1 meter, we need to include said height into our calculation.
How do we know height it will reach? Do we find its maximum height?
Exactly! And to find the maximum height, we first need to find the position vector of the ball. To find this, we must refer back to the velocity function that AMIRUL has obtained in 1a. Finding the position vector requires us to integrate our velocity function. So, yes, it is integral to find our solution. So, since we want to find the height, well, the maximum height of the ball, that means that we want to find the y of the ball. the vertically. So that's why we want to integrate our velocity function. So to find y of t, we need to integrate the velocity of t with respect to t, that is. So we continue on with our calculation by integrating our velocity function, and then after that, we get our initial function of our position function, and that have a c in it. So we need to solve for c. Since the ball is initially at the height of 1 meter, so we know that the ball is held at a time of 0. So at t of 0, the y at the t of 0 is equal to 1. So if we insert it as y is equal to 1 and as t of 0, we include that into our initial position vector function. So after doing the calculation, we find that the value of c is 1.298. So our final position function for yt is yt equal to negative 0.98t minus 0.298 exponent to the power of negative 0.10t plus 1.298. Now, from what INTAN has showed us in 1b, we know that the time for the ball to reach maximum height is t equal to 0.111 second, approximately that is. So, by that approximation, we can enter the time into our position function. So that means that the t of 0.111, we insert it into our position function. So with that, we calculate the entire equation, and we find that the approximate height of the ball hit from 1 meter will be 1.091 meter. That will be the answer to this question.
In this problem, we analyze the motion of tennis ball launched upward considering gravity and air resistance. The solution highlights how air resistance and the gravity interact to influence the ball motion. The calculation provided insight into its velocity, the time to reach its peak, and the maximum height achieved under realistic conditions.
Now, let's move to the next question. For this question, we need to determine whether Mr. X could be the killer in this case. So, what formula we need to use?
Newton's law of cooling.
Yes, Newton's law of cooling. Because of what? Because it describes the rate at which an object changes temperature in relation to its environment. This law can help us estimate the time of day based on the cooling of the body and compare it to Mr. X's whereabouts. So, from the question, we already know that Mr. X's check-in time is on 27 February at 11 p.m. And we want to find the time of day. So, we can write T equals to question mark and then 37 degrees Celsius for the normal body temperature of the dead body. We also know that the temperature after 1 hour is 34.5 degrees Celsius and after 2 hours it becomes 33.9 degrees Celsius. Room temperature is 15 degrees Celsius. The Newton's law formula is dt over dt equals to k multiplied with t minus tm. From the formula, we need to separate the variables of t and t, and we get 1 over t minus tm multiplied with dt equals to k dt. Then, integrates both sides, we get ln t minus tm equals to kt plus c. Then, we will get t minus tm equals to exponent power of kt plus c. Then, t minus tm equals to e power of kt multiplied with e power of c. And then, t minus tm equals to c e power of kt. And we get t equals to tm plus c e power of kt. And here, with t equals to tm plus c e power of kt, we can find c. We substitute the t equals to 0, while t equals to 34.5 degrees Celsius, and tm equals to 15. And we will get c equals 19.5. And substitute c equals to 19.5 into the second equation.
Next, to find k, we need to substitute t equals to 1h, t equals to 33.9 degrees Celsius into equation 2. So, from t equals to 15 plus 19.5 e power of kt, substitute the value of t, and we get k equals to negative 0.031253. After that, we substitute the value of k into equation 2, and we get t equals to 15 plus 19.5 e power of negative 0.031253t, and we can assume this equation is equation 3. From the equation 3, we need to find the time of the death when the body temperature of the human body is 37 degrees Celsius. So, t equals to 15 plus 19.5 e power of negative 0.031253t. We substitute the value of t, which is 37, and we get t equals to negative 3 at 597 hours. Now, is Mr. X is the killer? Let's find out. We already know that time of the death is t equals to negative 3 at 597 hours. So we convert to AM or PM and we get 11 at PM. Based on the estimate time of the death and the timeline of Mr. X was not in the area around the time of the murder, and it showed that Mr. X is not the killer. I think that's all from me. Any question?
I have one question. Why the value of K is negative?
K is negative value because K is cooling constant. Cooling makes the temperature will drop.